Today's lesson is 12.6, and it's actually a review of a topic that we covered back in Chapter 6, Section 6.8 to be exact. Back in 6.8, we introduced a means of expanding binomials using the Binomial Theorem. And we also expanded using Pascal's triangle. Well, we not only expanded binomials using the Binomial Theorem, but we also used the theorem to help us calculate certain types of probability problems. Probability problems that involve two possible outcomes, an outcome of success or an outcome of failure. So that's really what we're going to be doing again in this lesson. It's called binomial distributions, but you will see that, as my note here, do you remember how the binomial theorem works when we're using it to calculate probabilities of two possible outcomes? It's P stands for the outcome of success, and Q stands for an outcome of failure. So let me just throw a problem like we've had in the past, and just as a way to refresh your memory. Well, let's just imagine that we have this Major League Baseball player who's hitting right at, we would say, 300, which means that he's successful hitting 30% of the time. Well, P would stand for 0.30, or the decimal form of 30%. Well, that means that he's not successful at the plate 70% of the time, and that's what Q represents. N stands for the number of times, number of trials is the word we use in statistics, but applying it to this particular problem, if I want to know the likelihood of his getting a hit 7 times out of the next 20, okay, if I want to know the likelihood of this particular person who's successful 30% of the time getting a hit safely in 7 out of his next 20 at-bats, then I would raise this success likelihood to the 7th power, which means that if he's successful 7 times out of 20, then he must be failing 13 out of 20. And then remember, these get multiplied together along with a combination factor, which is made up of these two exponents added together, will be the first number. And the second number always matches up with the failure percentage, because remember, this is really just one, in this case, of 21 terms in the expansion. If I'm raising a binomial to the 20th power, then I'm going to have 21 terms as a result in the complete expansion. Well, this one term only gives me one of the probabilities, and that is the probability of getting 7 hits out of the next 20 at-bats. Okay, so I just wanted to review with you a little bit, because this entire lesson is really just going back to what we've talked about in Section 6.8. So let me apply it to some homework problems. What I'm about to do is very much like your 4 problems, 8 through 11, on page 675. Here we're told that the variable x represents successes, n is the number of trials, and the variable p is the probability percentage of success. Number of successes, likelihood of success is the way those are worded. So once again, if 0.25 is my likelihood of success, it's p, then I must have q 0.75 as the likelihood of failure. And remember, x is the number of successes, and in this case, that's 2. So I'm going to raise the success probability to the 2nd power, which means that if there are 5 total trials, if I succeeded twice, then I must have failed 3 times. Okay? And then my combination factor will be total number of trials and then this failure exponent, which is 3. And as I've told you in your notes, all of these are going to be in decimal form, rounded to 4 decimal places. So at this point, you can just take your calculator. I'm going to do 5 NCR 3 times 0.25 raised to the second times 0.75 raised to the third. And my final answer, rounded to the 4th decimal place, decimal form, is 0.2637. Alright? And then we did one more of these in class. So here my probability percentage of success is 70%, or 0.7. That's P, which means Q, the probability percentage of failure, will be 0.3, or 30%. Apparently, I had 8 successes out of a total of 10 trials. So if I succeeded 8 times, then I must have failed twice. And then, coming up with the combination factor, again, 10 trials. Let this number that follows C always match up with the exponent for failure. And let's use our calculator. 10 NCR 2 times 0.7 raised to the 8th times 0.3 raised to the second. And our rounded answer to the 4th decimal place is 0.2335. Alright? Very good. So you'll do 6 of those. 4 of those, problems 8, 9, 10, and 11. Alright, and then I just have one other example. We're going to skip over these problems. I'm shortening the assignment a little bit tonight. So I'm hoping to do this one word problem, and hope that will help you with these 6 problems, 15 through 20. Just read the directions carefully. I want to point out something that makes this problem a little bit different than what we did previously. We're trying to launch this weather balloon on one of the next 3 mornings. Okay, so right away we've got 3 trials, or in other words, n equals 3. For each morning there's a 40% chance of suitable weather. So I'm going to call 0.40, I'll label it as suitable weather. That would be success. And there's therefore a 0.60 chance of not suitable weather. Alright, now what is this looking for? What is the probability that there will be at least, interesting, at least one morning with suitable weather? Well, if all it did was ask for the probability that there will be exactly one morning, well, that would be pretty easy. I would raise suitable weather likelihood to the first, which means if there's only 3 mornings, that there would be 2 mornings of not suitable weather. And this would be my combination factor, and I would use my calculator. But it didn't say exactly one morning, it said at least, which means not only do I have to find the likelihood of one morning, but I also have to find 2 mornings. Okay, that would look like this. 2 mornings of suitable weather, meaning 1 morning of not suitable weather. Combination factor. And not only that, I'm also, since there's a total of 3 mornings, there's a possibility that all 3 could be suitable, since it says at least 1. So, once again, suitable weather. If all 3 mornings are suitable, then I want to raise that probability percentage to the third, which means that this would be raised to the 0. Okay, so in this case, I'm going to find 3 different terms of the expansion, the complete expansion. And then I'm going to add all of these together. Okay, so let's just go ahead and work through these. So 3 NCR 2 times 0.4 to the first, which is just 0.4, times 0.6 squared. That gives me 0.432. Okay, that's with one success. Well, two successes, let's get that. So 3 NCR 1 times 0.4 squared times 0.6 to the first. 0.288. Got a little better. And then finally, let's do this last term in the expansion, 3 NCR 0 times 0.4 to the third times 0.6 to the 0, which we know is just 1, and that's 0.064. Okay, now I need to add these three decimals together to get my final answer. So let's see if we get the same thing. And my final answer here is 0.784. Okay, so read the question carefully. If it says exactly and then a certain number, then you're only doing one term in the expansion, but you may see a phrase like at least or at most or something along those lines, which denotes we're going to have a range of these terms of the expansion that will have to be calculated and then added together. All right, so this is the assignment for this lesson. Pretty short. Just contact me if you have any questions.